Hi folks, this is your asynchronous video to teach you how to draw Lewis structures. So Lewis structures are a way to model covalent compounds, and that's our learning target. By the end of this video, hopefully you'll be able to model covalent compounds using these Lewis structures we're going to look at. What is the purpose of a Lewis structure? There are three of them. The first purpose is to show how electrons are shared in covalent compounds, specifically the valence electrons. The next purpose from that is if we know where the electrons live in a compound, we can begin to predict the shape of that covalent compound. And it's really important to know the shape of those covalent compounds because the shape begins to predict the behavior in terms of melting point, boiling point, conductivity, and solubility, the same physical properties we talked about in the ionic versus covalent lab. So historical context here, Gilbert and Lewis introduced the method of diagramming covalent compounds in 1916. Those are some of his earliest Lewis structures. Yours are not going to be as complex as this. Don't worry about it. And there is the official definition up there. Lewis structure is a diagram of a covalent compound to show where electrons live in a molecule. So let's get to the how-to. Before we get to the how-to, please remind yourself how many valence electrons are found in each element in a covalent compound. Remember that the Roman numeral, I'm just going to say Roman numeral, with the A by it gives you the number of valence electrons. So group 1, 1A has 1 valence electron. This one will have 2 valence electrons, 3 valence electrons, 4 valence electrons, 5, 6, 7, 8 valence electrons. So these are important to know because that's going to indicate how many electrons to draw in our Lewis dot diagrams. So now let's draw our first Lewis structure. We're going to draw a Lewis structure for water. And if you haven't learned that already, water has the formula H2O. When I draw this Lewis structure, I'm going to start with the atom that's all by itself. In this case, it's going to be oxygen. So that's the one I'm going to start with. And I'm going to look at my periodic table, and I'm going to find how many valence electrons surround this oxygen. And I remind myself, oh, there's 6, because it's in group 6A. So I go 1, 2, 3, 4, 5, 6. And then molecules love to be symmetrical. So what I'm going to do here is I'm going to distribute the 2 hydrogens to either side of the oxygen because in nature we like things to be symmetrical. So hydrogen each has 1 valence electron. And now we're going to want to fulfill the octet or duet rule where hydrogen wants to be like helium with 2 valence electrons, and oxygen will like to be like neon with 8 valence electrons. So they will share electrons to make themselves look like noble gases. Well, here are the 2 that oxygen and hydrogen are going to share there, and there's the 2 that oxygen and hydrogen are going to share there. And when they share 2 electrons in order to complete their octet, we make what's called a bond. And we also have 2 sets of electrons that are not bonded yet, and so we call these unbonded pairs. And they're really important to talk about the physical properties of these different compounds, but we'll get to that a little bit later on. So there's your first Lewis structure for water, where you made 2 bonds between each hydrogen and oxygen, and then you found the oxygen has 2 unbonded pairs to fulfill its octet. So to continue teaching us about Lewis structures, Tyrion is making an appearance. Tyrion is going to walk us through drawing the Lewis dot diagram for methane. So We're going to start once again with the atom that is by itself. Well, Tyrion's not going to teach us about methane, which is fine. He'd probably mess it up anyways. So I'm going to start with my carbon. Carbon has 4 valence electrons. So I put them at the 4 corners. And then remembering that molecules love to be symmetrical, I'm going to distribute the 4 hydrogens around all 4 corners of the carbon and assign the hydrogens valence electrons. And you can clearly see now where these bonds are going to form. There's a bond between the hydrogen and carbon. There's a bond between the hydrogen and carbon. 3, 4 bonds. So here we have these 4 bonds, each bond containing 2 electrons. And that's my Lewis structure for methane. There are no unbonded electrons in methane. So here comes one that is slightly trickier. And now we're going to deal with another gas called ethane. We're going to start with the same process. We're going to draw the Lewis dot diagrams for carbon. And then we're going to distribute 2 hydrogens per carbon, because reminding ourselves that molecules like to be symmetrical. So each carbon is going to get 2. Here comes the valence electrons for hydrogen. And now we're going to start making our bonds. I can see I can make a bond here between hydrogen and carbon, here between hydrogen and carbon, here, and here. I can also now see that the carbon is going to share these 2, but now carbon has 2 more to share, so I'm going to share those inside of there. So what I have done now is I have moved those electrons to show that they're shared between the 2 carbons. So now not only have we created a single bond inside of those carbons, we now have what we call a double bond. So carbons can share more than 2 electrons. They can share 4 electrons. And we can actually share in carbon up to 6 electrons. And I will show you that example on the next slide. Before I move on to the next slide, I just wanted to point out that I just changed. I had a typo. Don't feel like redoing the whole video. I misnamed this. This wasn't ethane. This was ethene, E-N-E. Not a big deal. So here comes our next example. Here's ethyne gas. So ethyne gas has only 2 carbons, 2 hydrogens. 2 carbons, 2 hydrogens. So here comes my carbons, 2 carbons like this. Each carbon has 4 valence electrons. Here comes my 2 hydrogens spread out evenly amongst the 2 carbons. Here's their valence electrons. Here comes a bond here. Here comes a bond here. And carbon can share 2, 4, 6 electrons here to make a triple bond. So that's going to be a triple bond there. Why we care so much about the number of bonds that can form is the more bonds you have, the more energy that's contained in those bonds. So it takes more energy to break those bonds. We'll talk about that maybe before the end of the year. So here's our last example. This is going to be another example with a lone pair. This is ammonia, so something different than a carbon. We are going to have a nitrogen that has 5 valence electrons, 2, 3, 4, 5. And then in the 3 additional corners where there are single electrons, we'll place where the hydrogens will be. Then what I'll do is I will add the valence electrons for the hydrogens, and I will see that there will be 3 single bonds that are formed. One here, and one here. So you'll notice that there are 3 single bonds. Those are the 3 bonds. And then here's my 1 unshared pair. And when we start to talk about polarity, you will begin to understand why this unshared pair really is important to discern whether a molecule is polar or nonpolar. Last thing in this particular unit is going to be to draw long organic chains where you don't always have to count electrons. And so sometimes it's really a pain to always draw out those valence electrons when you are drawing out a Lewis structure. So I'm going to introduce you to what's called the HONC 1, 2, 3, 4 rule. H stands for hydrogen, O stands for oxygen, N stands for nitrogen, C stands for carbon. Those are the 4 major components in any organic compound. And 1, 2, 3, 4 means that hydrogen gets 1 bond, always, always. Oxygen only gets 2 bonds, always, always. Nitrogen gets 3 bonds, and carbon will get 4 bonds. Carbon is interesting. It will never have lone pairs. It'll never have lone pairs. Carbon will always form 4 bonds. So let's see how this works. So I'm going to show you how to draw the Lewis structure for this compound, which is called methanol. I'm just going to tell you that, and if I have time, I'll tell you how I knew it was methanol. And I read an organic compound, and I know it's organic because it has carbon in it, left to right. So I'm going to start with carbon, and according to HONC 1, 2, 3, 4, carbon gets 4 bonds. So here comes its 4 bonds. Remember, those bonds each contain 2 electrons. Then I read the next element. There's 3 hydrogens that are going to be attached to the first carbon. So I'm going to say hydrogen, hydrogen, hydrogen. And then I still have an empty bond here, which is where the oxygen will be filled in. And now carbon is filled up with its 4 bonds. I remind myself that oxygen wants 2 bonds. So there's the second bond, and then the last hydrogen is attached. Now I can clean this up because I can see that oxygen right now does not have 8 valence electrons surrounding it, and it wants to be like a noble gas. So 2, 4, 6, 8. And that's how I can use the HONC 1, 2, 3, 4 rule in order to draw longer organic compounds without always having to just count out valence electrons. All right, with that being said, attached to this assignment, you're going to see some Lewis structures to draw out. And we're going to do just a quick review of that when I see you next week on Thursday or Tuesday. Have a great Memorial Day weekend. Enjoy the sunshine.